copy this down. Square root inequalities are going to be pretty straightforward to solve, but the one thing that you have to pay attention to that's going to be different than if it's an equation sign or an equal sign is that you have to think about the domain of square roots. So we've talked about the domain of square roots whenever we were graphing them before, and we know that whatever is under the square root has to be greater than or equal to 0 because we can't be taking the square roots of negatives. The stuff under the square root is called the radicand. So that's why I have written here the radicand has to be greater than or equal to 0. This is your radicand. So before we start any inequality problem with the square root, we want to think about that domain. So we are going to take that domain there, and we are going to say that 2x plus 1 has to be greater than or equal to 0. And if we solve that, that would mean that 2x has to be greater than or equal to negative 1. So x has to be greater than or equal to negative 1/2. So this has to be true for this equation. It may or may not conflict with part of our solution, right? So you may end up using this, and it may not end up changing anything about your answer depending on the problem. But we have to think about it at the beginning of every one of these problems. So once we have this set up, we are just going to solve this inequality just like we solve regular equations. So we're going to add 7 to both sides to get that over to the other side. So we'll have square root of 2x plus 1 is less than 11. We will square both sides to get rid of that square root. So 2x plus 1 is less than 121. Subtract your 1. 2x is less than 120. And divide by 2. X is less than 60. So x is less than 60 is our answer for this problem, but we have to think about the domain of this problem as well, right? Because, and the way that I usually do this, you can do this mentally if that works for you, but you might need to actually write it down. So whenever I've got 60 and I've got a negative 1/2. So my answer here is that x is less than 60. But I also know that x has to be greater than or equal to 1/2, right? So my answer is only where these two overlap. Because if we're thinking of numbers less than 60, most of our numbers less than 60 that we're probably going to think of, the positive ones, are going to work. But when we start getting down to those negative ones, those numbers don't work anymore because they're not in our domain, right? So we would just be looking at the overlap which would be this part here. So our answer, our final answer to this problem would have to be negative 1/2 less than or equal to x less than 60. Or we could write it this way, negative 1/2 with a bracket, comma 60 with a parentheses. The biggest problem students have on this is usually not solving. It's usually just that they forget to think about the domain. They just solve it and get x is less than 60. Similar to that second problem on our warm-up, right? A little different because it was a radical, which we had to make the chart for. But if you just solved it, you got part of it, but you didn't have that restriction there that you needed. So let's look at another problem. So for example 2, we've got 3 square root of x minus 5 is greater than or equal to 36. So I want to just go ahead and start solving this, but before I do, I need to think about the domain. So x minus 5 must be greater than or equal to 0. Okay, we've always got to deal with that. So we're going to move the 5 over to the other side, so x has to be greater than or equal to 5. So I can't have any numbers that are less than 5 because that would not satisfy this situation right here. So we're just going to put that to the side. We're going to solve this equation. So Reese, what would I do first to solve that inequality? We do. And that 3 is right next to that square root, which means it's multiplied by that square root. So how do we reverse that? We're going to divide it. So we're going to have the square root of x minus 5 is greater than or equal to 12. Okay. Grace, what comes after that? Yep. So we'll get x minus 5 greater than or equal to 144. And then Hallie, what's the last step on that? What? 149. Good. So we just add that 5 over to the other side. Okay, so when we're thinking about our answer for this, our answer, we got our 5 here and our 149. So our answer is x is greater than or equal to 149. So it's this part. But we have to consider our domain restriction, which is that 5 is greater than or equal to, x is greater than or equal to 5. Now, does our domain restriction affect our answer here? It does not, because anything that is greater than 149 is also going to be greater than or equal to 5, right? So the overlap of these two right here only happens for x is greater than or equal to 149. So this is a problem where if you forgot to consider the domain, it would actually be okay because the domain doesn't affect this here for this problem. But there are lots of them where the domain does affect the problem, so you need to check it every time. Okay. Questions? How do you read it? Right. You would just write, for this one, you would just write x is greater than or equal to 149, or you could write it this way, bracket 149, comma, infinity. So either one of those, whichever you prefer. You would not include the 5 at all, because your answer is where these two overlap, And they do not overlap anywhere between 5 and 149, so it's just the numbers bigger than 149. So sometimes that domain needs to be included, but not always. It just depends on whether or not it affects what your answer is. Okay. All right, well, let's go to our next one. Now, this problem is not a square root, it's a fourth root. But if we have a fourth root or a sixth root or eighth root, any root that has an even power, then we still have to consider the domain. If that were a cube root, we would not consider the domain because we can take the cube root of negative numbers, or fifth root, or any odd number root. But we do have to consider it here. So I've got 2x plus 3 has to be greater than or equal to 0. So 2x is greater than or equal to negative 3. Divide off that 2. X is greater than or equal to negative 3 halves. And so, to get rid of a fourth root, Blaine, what do we have to do? To the fourth power. Very good. So we'll have 2x plus 3 is less than or equal to 3 to the fourth is going to be 81 there. Blaine, what would come next? Good. So I think we get x is less than or equal to 39 there. So whenever we think about our answer, is x is less than or equal to 39, but our domain says that x has to be greater than or equal to negative 3 halves. So this is going to affect, because we have this overlap here in between. So we would say that our final answer would be negative 3 halves less than or equal to x less than or equal to 39. Or we could write it with interval notation, negative 3 halves to 39. It is more likely that the domain is going to matter when you have a less than sign. I'm not going to say it never matters when you have a greater than sign, but it's more likely that it's going to affect. Okay. Questions on that one? All right, I've got one more that I want us to do. This is the most complicated type that you will see, which is not a great deal more complicated. The only big deal here is we've got two different radicands here. So we got to take both of those radicands and set them greater than or equal to 0. So we'll say m plus 8 is greater than or equal to 0. So m is greater than or equal to negative 8. We'll also take this one, 2m minus 6 is greater than or equal to 0. So 2m is greater than or equal to 6, and m would be greater than or equal to 3. Now you can, like when we get to the end, you could graph both of those, but do we really need both of those? if a number is greater than or equal to 3, is it also going to be greater than or equal to negative 8? It has to be, right? So like 4, 5, 6, 7, 8, 9, 10. All those numbers are also bigger than negative 8. So you could, if you want, just only consider this one right here because it's the larger of the two. Or you can look at both of them. So if we want to solve this, we're going to square both sides. And we'll have m plus 8 is less than or equal to 2m minus 6. So square roots will just go away on both sides. And so we will subtract the m and add our 6. So 14 is less than or equal to m. Or I like to turn that around so that the m is first. M is greater than or equal to 14. So for this problem, if I consider all three of these, which really I don't have to consider this one if I think about it, but I've got m is greater than or equal to 14. I've got m is greater than or equal to 3. And I've got m is greater than or equal to 8, or negative 8. But I'm looking for where all three of those overlap. So the only overlap I have is this section right here, which is actually just my m is greater than or equal to 14. Okay, questions? All right, so we are going to do